Hello, my name is Cole Dobbins Speck, and I am here with the Sprint 5 overview for the radar coding project in IST 361. So this is the milestone page on GitHub for the final sprint. There's three main issues that were assigned. One was to switch the authentication from using IP addresses to using a more secure cookie-based authentication mechanism. The other major issue was expanding the API permissions and the database access, so that way users have more control over retrieving the data. This was actually completed in Sprint 3. And then another major milestone for this sprint was to implement encryption on the server's API, the RESTful API. And this was actually completed in Sprint 2. So along with those three issues I just mentioned, there was a couple that were more oriented on improving visibility and usability. They were labeled won't fix because what I ended up doing was I refactored most of Radar to accommodate a different way of using it that is more expandable and easier to use. So because I made those changes, it's easier to actually have this functionality without directly implementing it. So just to give a better understanding of how Radar is currently laid out, you can have as many team members you want working with this program as you would like, and then the user uses either of the two clients depending on what they want to do. So there's the standard Radar client, which runs the system commands and then syncs that data. But then there's also the Radar internal client, which is used to control the state of the uplink and the server, as well as to retrieve data and run other useful functions like that. So both clients sync with the Radar uplink server via JSON remote procedure calls via HTTP server. So each team member computer runs their own instance of the Radar uplink server, and all of the Radar uplinks then connect with the central Radar control server over a RESTful API. This can be HTTP, but it's better to use HTTPS for the encryption since this is going to be over a network, since this is likely going to be over a network connection, and you don't want anyone snooping in on that data or modifying it. And then that central server then connects with the backend database, which is MongoDB. So this is just a quick diagram I threw together for how users interact with Radar and how it's laid out, essentially. Alright, so let's switch over to the user-facing demo. So I'm currently on my VM here, which is going to run the server. So I'm quickly going to edit the server config, make sure everything's up to date. This is actually a new VM, so I don't have the certificates installed. So I'm just going to delete that here, and then save the file, and then start the server. Alright, so it's running now. So then I'm going to hop over to my other terminal, and then I'm going to edit the uplink configuration. So the uplink is actually a second server that sits on each of the user machines. Since I'm not using HTTPS, I'm just going to set that equal to false here and save it. And what the uplink does is it facilitates the client connection to the server, and it acts as an intermediary. This is a service that runs, and you'll see that it successfully starts up here. So it's checking to see if data needs to be synced, and all of that looks good. So now I hop over to my third terminal window here, and I'm just going to list out the contents of the directory I'm in. You can see there's a few .py files in the Radar project. The two that are clients are client.py and Radar internal.py. So I'm going to take a look at the just standard client first. If I just run the client, it tells me I'm not using it correctly and I need to give it a command after I run it. So let me do that here. I'm just going to give it like the nmap command, so nmap localhost. Yep, that looks good. So I'm just going to hit enter and then it executes it just as if it was a system command that I was running normally. So it executes the command. I see the output here. It then parses it for any meaningful data, performs any automations, and then it syncs the data with the uplink, which then in turn takes that data and then sends it to the central server so it can be inserted into the database. I am just going to run one more command here, just to list the contents of the directory. Awesome. And then I'm going to clear the output here. All right, and now I'm going to go over the radar internal client. So if I run it with the -H option, I get the help menu. So it lists a bunch of commands that I can run as well as a description. I want to show off the document commands and get data option or commands. So I can say document commands -H to get more help about that specific command. And this says that I have to give it a file name of where I want to write the output to. So I'm going to just call it testdoc.txt. Hit enter here and it's going to take a few seconds to run, and then it's now done. If I open up my project folder, you'll see testdoc.txt. If I double click and open that up, you'll see it has like which command was executed, where it was executed, the exact time it was started and finished. This is useful for documentation because if a command might have negative impact on a system, you could say this command was running in this very specific time frame. So if an issue happened outside of that time frame, you know that it was not caused by your command. It also documents the full output of that command here, just like it would appear in the command line, and it does that for every command. In our example, we only had the 2 commands that I executed, but it'll do it for any number of commands depending on how many are in the current mission. Hopping back over to the terminal then. Alright, so let's go over that second command I mentioned. So -H. So let's go over the get data command. So get data -H. And you can see with this command I have a different set of arguments I can provide here. I can do -C to specify the collection and -D to specify the database. I know that that's optional because I programmed it. So we just need to know the collection. If I don't know the collections that are in the current mission that I'm in, I can use the collection list command. And you can see I run that. It'll take 1 second here, and then it will give me a list of all the collections. So now I can go back up to the get data command and use -C and let me read the targets collection. So I'll hit enter here. Give it a second, and then it returns all the JSON for the targets. Currently it's only the one host I nmapped, localhost. But you can imagine this is useful because I can then pipe this to a file and save the output that way, and then I could process it in future commands. So targets.json, and you can see now I have all of that output in a file, but I could very easily have piped that into another set of commands to then process this information as well. So that's a summary of how you can use Radar in its current state. And let's go over the code that drives that behavior. So this is the new client. the first thing it does is it gathers those arguments, so everything after the name of the script, and then it runs it through main. And in main, it just runs it as a system command, parses the output, runs playbooks, then sends it to the uplink. So this is similar to before, just without a looping behavior. The radar internal client is a bit more complex. So it uses argparse to have those command line arguments. And each of the commands is actually a subparser. Subparsers allow me to give it a different arguments depending on the command. So you can see this playbook command requires or has these arguments, but other commands such as getData have different arguments. So argparse actually guarantees that everything's being provided, all the arguments are being provided if they're required, and it normalizes the output for that. And then all I need to do is check which command was actually specified, gather the arguments as appropriate, and then run the method, which is pretty straightforward. Typically it's just a little wrapper to then do the same, have that same functionality from the uplink. So the client uplink uses a JSON remote procedure call framework. So simply say which method it is going to call, and then send a request to do that, and then read the response and return it. Pretty self-explanatory there. The uplink itself is a bit more complicated, so it's actually its own web server as well. So the actual uplink is similar to the old client actually. What it does is it loads its configuration, sets the certificate authority if that's specified in the configuration. It then creates a connection to the server and makes sure it's established. It then also starts a background task that automatically checks to see if data needs to be synced. And the uplink actually has that distributed watcher that will execute system commands. That's in the uplink now instead of the client. And it has these little methods here. You can see it has the @ symbol and then method. And these are actually the methods that can be called using the remote procedure call framework. So I don't really need to do anything special for them. I just have the name of the method and then any arguments. And then for syncing the data, all I would do is I have a list, and as new things come into sync, I put them in that list, and then the uplink checks to see if that link has data, and if so, it removes items from that list and then sends it to the server to be sent into the database. So actually, if this program shuts down, it'll actually first write all of the data to files on disk. That way it doesn't lose any data which it's waiting to sync. So if something kills this program and it doesn't expect it, it can actually shut down safely still. And the way the uplink connects to the server is similar to the way the client used to connect with the server. I accidentally hit 0 key. And the way that the uplink connects to the server is basically the exact same as the previous way the client used to connect with the server. So it's just using HTTP requests using a RESTful API. And the server didn't really have any modifications to it other than for the authentication, which I mentioned at the very start of this video. It moved away from using the IP address to using cookies. So the way it works is when you request authorization, it generates a token for you, and then it gives it to the client. And then when it checks for authorization, it expects to see that value in a cookie called key. So it checks that instead of just by IP address. So it authorizes it based on those 16 hex character tokens. So that's a very brief code walkthrough. Actually, a majority of my code changed for this sprint, so I don't have time to go over all of it, but that's a quick overview of what each class does and kind of the core functionality that it has. If you have any questions, I'd recommend you check out my GitHub. There's some good information on there, or check out my previous sprint videos.